Hello friends, today I'm going to show you my first prototype of my new project, the off-the-grid power system. On my back here is the whole system. This specifically, you see there's an inverter, the battery, and the battery management system. I will show you how the system works and how I build this one. Now my system, I am using it to power my monitor here. The goal is to test this system on smaller loads. As you can see, the monitor is powered by my off-the-grid system. So I am reading here, this monitor is drawing 3.4 ampere over from my battery, which is around 14.1 volts currently. So this is my off-the-grid power system. It composes of I should say three basic parts: the batteries, the battery management system, and the inverter. So the batteries are lithium-ion batteries, which I salvaged from old laptop batteries. And I use this power cord to connect the main negative and the main positive to the battery management system. This cord is also recycled. I also used a USB connection to connect the balancing terminal of the batteries. So this batteries is in 4S 4P configuration. So what I mean by that is I call this one group. This is in series with one group here, also in series with this and with this. So all in all, this will be around 16 volts. Although lithium-ion batteries are rated can go from the lowest should be 3.0 volts to 4.2 volts. So I just call this 16 volts battery. This battery management system manages the battery. You can get the voltage, current, and temperature information of the battery, and it also manages the safety of the system, which means if there's an overcurrent event, it will automatically disconnect the battery from the inverter, as well as over temperature also. So it does that by using a relay inside to disconnect the batteries in case of such error events. It also detects the voltage level of each cell here. So because lithium-ion batteries, you should not drain them below 3.0 volts, or else you can cause damage to the batteries, or worse, it can damage them, and then it can cause fire. It can explode actually. So I will open that later. First, I'll show you the inverter. This is the inverter. This is a pure sine wave inverter, rated 600 watts. So the input from the inverter is coming from the BMS, the battery management system here. The input is rated 12 volts. The output is rated 230 volts, 50 hertz. So which is hooked up to my monitor here. So now I'm going to turn it on to show you how it works. You see, on this display here that I made, you can see the battery management system reads the voltage of the battery as 14.8 volts. And it's currently drawing 50 milliamps. As you can see, I have the V1 is 3.6, V2 is 3.6, V3 3.6, and V4 is 3.7 with a temperature of 29 degrees Celsius, and it's currently running okay. That's why it has a status of okay. So if one of those if battery groups drops to 3.1, then it will automatically shut off the battery to prevent damage to the batteries. So I'll explain to you here. So the battery comes from here, and I have the switch. It goes to this switch, and then where it goes is from to this board, to this elongated board, the white one. This is a fuel gauge board from some old pop batteries. So from here I am able to get voltage information of the batteries, because all the batteries are connected to this board. Also the current it supplies to the load, as well as the temperature. And then I am getting the data from this fuel gauge board through using a microcontroller. This is an STM32 microcontroller. You can communicate with this board through I2C to get those information. And then this STM board is also powered by the battery, so I have to use a DC-DC converter. This is a buck converter to step down the voltage. And then the output of this fuel gauge, the output of this fuel gauge board is fed to this buck converter to step down the voltage to the required voltage input of the inverter. Because I have mentioned before, this battery can range from 12 volts to 16.4 volts. That is because these are lithium-ion batteries, and the ratings of this inverter is only 12 volts. So I have to make sure I always feed the inverter 12 volts, or at least the minimum it can accept. So I have to use a buck converter to do that efficiently. So, and then I have this OLED display to display the values I get from the fuel gauge board. Whenever there's a battery that's less than 3.1 volts, to prevent damage to the batteries, I trip down the connection. This is done by using a relay here. There's a relay. It's controlled by my controller also. As you can see, there's only 0.65 amperes of current draw because the monitor, which is the load, is turned off. So if I turn it on, you should see a increase in current draw. As you can see, there's a 3.28 amperes, 3.3 amperes draw. That's the monitor is on. So it's around 48 watts, should be, which means this monitor is drawing 48 watts from those batteries. So I do check this buck converter if it gets too hot. I can hold it by hand, so it's okay. Actually, I have the Fluke temperature meter here, so we can test this one. So it's around 45. The highest is 45. I can see 45 degrees Celsius. It's around 45 degrees. Still okay. And the batteries are all 35, 36, 41. It's not that, oh, it's 41. Oh no, because I have to change the EMS here. It's the correct one. It's 32, 33. Because the emissivity of these batteries is different. If you're measuring aluminum, you should set it to low on 45 degrees. It's okay. So this is my first prototype of my off-grid backup power system. So there will be a plan to improve this. One improvement I can make with this battery management system is to add a charging circuit, which means I can charge using this also, either from an AC main or from a solar panel or from my windmill to charge my batteries. Also, to make this battery management system smart, I can put a Bluetooth or Wi-Fi connectivities here to control and monitor them. This battery management system from a remote device, a cell phone or a computer maybe. So that's it for now. Thanks. Currently, the improvements I will have to do with this is to add the charging circuit, which means I should be able to hook it up to a solar panels or windmills to charge the batteries. Hopefully in the next few months I will be able to design the charging circuit for it. That's all for now. Thanks.